Welcome to Paradigms of Computer Programming. I'm Peter Van Rooij and I will be teaching this course. Let me first start by explaining what motivates the course and how we organize it. First of all, this course is rather ambitious. We aim to teach programming as a unified discipline that covers all programming languages. So we're not going to focus on any particular language. We want to teach programming. We will cover, in our view, the essential concepts and techniques in a uniform framework. The level is second year university, so we assume some knowledge of programming in at least one language, so you know what a program is. We also assume a little bit of mathematics. You know what a set is, a list is, and a function is. And we will be covering programming in 4 themes, so paradigms, mathematical semantics, data abstraction, and concurrency, which is a very important topic. Now let's see how this works in practice. So how can we do it? Hundreds of programming languages are in practical use in industry. And here in this figure, I've shown you some of the languages which have particularly nice icons, but in fact there's many, many more. But here we already have some of the many languages in our use. So how can we teach programming with so many different languages? Each language has its own way of doing things. How can we understand them all? So we have so many languages, hundreds. Well, the key insight that we will use is that languages are based on what we call programming paradigms. And there are many fewer paradigms than languages. So, for example, in all we have counted around 30 paradigms, and in this course we will see a number of the very important paradigms. So the point is we can understand many languages, many, by just learning a few paradigms. That's the first point. So what is a programming paradigm? Well, a programming paradigm is an approach to programming a computer based on a coherent set of principles or mathematical theory. So a mathematical theory could be something like a process calculus or lambda calculus. A set of principles could be a set of ideas that you use for structuring programs, data abstraction, object-oriented programming. Okay, so once we know this, what good is a paradigm? Because in fact, programs are written to solve problems. Well, it turns out any realistic program needs to solve different kinds of problems. And each kind of problem, in fact, needs its own paradigm. It's like when building a house, you need a different discipline for handling the electrical wiring, the plumbing, the heating, the isolation, building the walls, building the basement, etc., etc. You need many different paradigms. So in fact, we need multiple paradigms and we need to combine them in the same program. So the next question, how can we study multiple paradigms? How can we study multiple paradigms without studying multiple languages? Since most programming languages only support 1 or sometimes 2 paradigms, how can we handle so many different paradigms? And in fact, organizing a course around multiple programming languages is quite difficult. Each language has its own syntax, its own semantics, behavior, its own system that has to be installed and maintained, and its own funny quirks that you have to get used to. So we could do that. People have done that. We could pick 3 languages, for example, Java, Erlang, and Haskell, and structure our course around that. But still, that would be very complicated. You would have to learn 3 systems, and in any case, the languages don't really talk well to each other, so it would be very hard to combine them. So things would be complicated. So in order to get around this problem, we have a pragmatic solution. We will use a research language called Oz. A language that has been designed to contain many paradigms over 20 years of research, and this will let us focus on the real issues. We're not really interested in Oz as itself. The point is, we hope that Oz kind of gets out of the way, so it lets you really understand the concepts. And the textbook that we'll be using, Concepts, Techniques, and Models of Computer Programming, is uniformly based on Oz and covers very many paradigms. And in fact, our course will cover approximately 1/3 of this book. So that's the point. We will use Oz now. We use Oz so we don't have to learn very many languages to learn many paradigms. The second point, how can we combine paradigms in a program. Each paradigm is really a different way of thinking. It's like an electrical engineer and a mechanical engineer. They have their own concepts, their own terminology, their own reasoning techniques. How can you combine that? How can you combine different ways of thinking in the same program? Seems to be very hard. In fact, our solution is based on the concept of a kernel language. Each paradigm in our research, we found that each paradigm is based on a very simple core language called its kernel language, which contains the essential concepts. So every practical language, even a complicated one like C++ or Scala or Java or C# or whatever, very complicated languages, they can be translated quite simply into kernel languages. And what's more, even very different paradigms have very similar kernel languages. The kernel languages have much in common. And very often, between even two very different paradigms, there's maybe only one concept difference. So in fact, there's so much common between the two languages, the two paradigms, that they can in fact talk to each other. So in this course, we will start with a simple kernel language that underlies our first paradigm, which is called functional programming, and then we will add concepts one by one to give the other paradigms. So this is an example of the scientific method, understanding a complicated system in terms of its component parts, a paradigm in terms of its concepts. So to summarize quickly the approach, first of all, hundreds of languages are used in practice. We cannot study them all in one course or one lifetime. The solution is to focus on paradigms, since a language is based on a paradigm and there are many fewer useful paradigms than languages. Second point, one language per paradigm is already too much for a course, because each language is already a complicated beast, a system with quirks, semantics, syntax, etc. Solution using one research language, Oz, that can express many paradigms in a nice, clean, well-factored way. Third point, realistic programs solving different problems need to combine paradigms, but how can we do it since paradigms are different ways of thinking? Solution, define paradigms in terms of their simple core kernel languages. And even very different paradigms have kernel languages with much in common. So we can focus on the differences because they have much in common. It's much more economical in time and effort, and it lets the languages talk to each other. Okay? So now we can get started. Probably you already know an object-oriented language, because in fact, object-oriented programming with its coherent principles, it's clearly an important paradigm. It's very widely used in industry. So what can we say? What about the other paradigms? Isn't object-oriented programming by far the most important and useful paradigm? Actually, it's not. Completely not. Many other paradigms are extremely useful and often much more than object-oriented programming. For example, if you want to make robust and reliable distributed programs on the internet, object-oriented programming just does not give you the right toolbox to solve the problem. You need to do something else. So another paradigm, for example, multi-agent data flow programming, which we will see in this course, is much, much better suited for building reliable internet programs. So in this course, we will cover 4 paradigms that are quite different and solve different problems. So the 4 paradigms are functional programming, object-oriented programming, deterministic data flow programming, the simplest form of concurrency, and multi-agent programming, which is in fact a bonus lesson because this lesson was not mentioned in the original video. But after discussion with my colleagues, we decided this one is so nice that it would be really a shame not to put it in, because in our view it's the best one for doing general purpose concurrent programming. So we put it in. And in our view, these are probably the most important programming paradigms for general use. Your mileage may vary. You may not agree with us. In fact, we hope that you will have some discussions with us on this, because we, of course, are very interested in learning more. And what I'm showing you here is just a snapshot of our understanding. We will understand 4 paradigms after doing this course, but in fact, many, many, many more ideas are presented than paradigms. Basic ideas such as identifiers, environments, starting with functional programming, of course, recursion, programming with invariants, with lists, trees, and records, so symbolic programming, and then instantiation, genericity leading to higher order programming, kernel languages, abstract machines, mathematical semantics, explicit state, data abstraction, polymorphism, inheritance leading to object-oriented programming, exception handling, data flow synchronization leading to deterministic concurrency, non-determinism, and finally multi-agent data flow programming. And so we will have really seen a very wide spectrum of ideas. So what are the next steps? So in this lesson, the next video, we're going to talk about the practical organization of the course. So in fact, we will have 13 lessons, 12 lessons plus the bonus lesson on multi-agent data flow. This will be 10 weeks, so we will either have 1 or 2 lessons per week, and then we'll have 2 weeks when we only have an exam, so we'll have a midterm and a final exam. We also have many exercises. The exercise and exam are not required. If you want to get the certificate, of course, you have to do them. They're not required, but we do recommend it. We do recommend them. Even if you're seasoned professionals, you may still get something out of them. And in order to do the programming exercises, we have a platform called Pythia, which gives feedback on the particular errors you made. And this platform is based on the Mozart programming system, which implements the Oz language. So you will have to install Mozart and use Mozart. And when we will talk about our first paradigm in this lesson, functional programming, we'll start by giving interactive examples and show some fundamental programming concepts.